Hey guys, Mrs. Sands here. So we're on lesson 8. Here's you getting ready. You have to write down that objective that we're going to be solving fractional equations. And we will observe multiple methods. So in the end, you kind of get to choose the method you like best. Because when we're dealing with fractions, there's a few different ways of approaching it. So whatever makes you feel most comfortable, as long as you're following mathematical procedures, that will be great. I would prefer you hit pause, do the do now, and then check back and make sure it turned out okay. And I'll go over the do now and do a few numbers with you. And your homework starts on page 31. Notice you're doing it all, you're solving and checking. So let's go take a look. So the do now says that Gabby did not solve the problem correctly. And we have to make note of the mistakes she made. There are a few of them. And are there any of her steps that were done correctly? And if this was worth 6 points, how many points do you think she deserves? So this is like the predicament I'm in when I'm grading your tests. I really do have to look and see, what did you do? What did you do right? What kind of mistakes did you make? So from this first step to this second step, you're supposed to distribute. Okay, that's definitely what you should have, what Gabby should have did. But we can see she actually added this 1 and this 2. I guess that's how she got that 3. I have to tell you, that's like a major mistake. You can't do such a thing. So she's going to lose quite a bit of credit for doing that. So let's write down that it says make notes of the mistakes and are any steps correct. So the first step, she should have distributed. Right? Even like the order of operations, say that you have to do parentheses. Adding comes way later in the order of operations. You're not allowed to combine the 1 and 2. But we have to we have to just continue looking at her work. This is what Gabby thinks is correct. So now from here to here, did she make any mistakes? Looks like she distributed right? She got a 9a minus 12, so that's really nice. And then this is a negative 1, that should be distributed. So she has a negative 2a, and oh no, Gabby, negative 1 times 3, this should have been a minus 3, right? Or a plus a negative 3. Oh, so she distributed the 3 right. But she didn't distribute the negative correctly. And now we have to, again, look from one step to the next. So Gabby thinks that this step is right, so then of course she would continue. If this step was right, she should combine the 9a and the negative 2a, and that is a 7a, and then she should combine the negative 12 and the 3, and that is a negative 9. Oh good, Gabby knows how to combine like terms, so I'm going to say she combined like terms correctly. But how much is this worth, right? It's a 6-point question. I told you that very first step is like a major mistake, really major. It knocks her down like 3 or 4 points. And then she only made one other mistake, and it was forgetting to distribute the negative all the way through. It's a 6-point question. I really think she only gets 2 out of 6. And now I'm going to teach you about equations for fractions. Now I think you might be able to do number 1, and notice how it's set up so that we can do it 2 different ways. One way that a lot of you might think about is this first way. You might think about multiplying both sides by 4. So you have 3x equals 36, and divide both sides by 3, so x equals 12. And if you like that, great, maybe that's the method you're going to use. But I do need to point out that if you have something that we call a fractional coefficient, this 3x over 4 equals 9, we're also allowed to write it as 3/4 x equals 9, right? That really says the same thing. So the coefficient of x is actually a fraction. The coefficient of x is 3/4. You can eliminate a fractional coefficient by multiplying by the reciprocal. If I multiply this by 4 over 3, and the 4's simplify out to be 1, and the 3's simplify out to be 1, and all I'm left with is an x on the left side, and that's exactly what I wanted. So I wrote 4/3 on the left side. Remember, whatever you do to one side, you have to do to the other. So I have to multiply by 4/3 again. I'm going to think about this 9 as a fraction so that I can now simplify. I know that the 3 and the 9 simplify. And now if I multiply the top numbers, I get 12. And if I multiply the bottom numbers, I get 1. So guess what? I have the same answer. 12 over 1 is the same thing as 12. So I don't care what method you use. I don't care if you multiply by the reciprocal or if you first divide and then multiply. It really gets you the same results. On number 2, I would really only use one method. I'm not going to do it 2 different ways. I really think that we should all add 2 to both sides. So we're left with 2/3 x equals 8. And then I guess if you really wanted to, you could divide by 3 and then multiply by 2, but I'm kind of a reciprocal kind of person. When I see a fractional coefficient, I do multiply by the reciprocal. It just makes the whole thing go away so quickly, right? The 3's cancel, the 2's cancel. So I like using a reciprocal. I feel like I get more done in one step. So I just put a 1 underneath this and I simplify, and this turns out to be 12. Let's just make a note for ourselves about this fractional coefficient. If you have a fractional coefficient, you can multiply both sides by the reciprocal. This multiply by the reciprocal should always be your last step. So I'm going to say as a last step in the equation. We don't like multiplying by the reciprocal like in the middle of an equation. Not usually, actually. I don't know. Let's see. Number 3. So your first instinct is probably to distribute. That might be the way that you really want to do this, but I am going to do number 3 2 different ways to show you something. So 1/3 times 4 is 4/3 p. And then 1/3 times 6. And again, if you're not good with your fractions, go write it to the side. 1/3 times 6, I hope you see it as 2, right? It's 6 over 3, so it's a 2. And then if I'm going to continue to solve, I have to add 2 to both sides. So now I have 4/3 p equals, I think adding a whole number with a fraction is an easy task. 2/3 plus 2 is really 2 and 2/3. And I'm a reciprocal kind of person, so I'm going to want to multiply both sides by the reciprocal. Now, when you are multiplying with fractions, you really can't have mixed numbers. So if I write multiply by 3/4 here and multiply by 3/4 here, I'm a little stuck. I can't multiply that just yet. I have to change the 2 2/3 to an improper fraction. Remember, you do 2 times 3 and then you add on the 2. So 6 plus 2 is 8/3, and I'm multiplying that by 3/4. So now I'm going to simplify that fraction. So the 3's simplify to be 1, and the 4 is a 1, and the 8 is a 2, so I get P is 2. We are going to attempt this a different way. So when you see a few fractions in a problem, if you look at the denominator, there's actually a way of getting rid of the denominator and therefore not having fractions anymore. If you can find the common denominator between any fractions you see in an equation problem, you can actually remove that denominator. So I say the common denominator is 3. So I have to take this side and multiply it by 3, and this side and multiply it by 3. And this is kind of like an unusual way, but it gets rid of fractions. To eliminate fractions in an equation, I spelled fractions wrong, in an equation, you can multiply both sides by the common denominator. That common denominator is actually a common multiple. I'm going to call it the common denominator, though. So a 3 and a 3, what's in common? Oh, it's 3. So I multiplied both sides by the common denominator. It makes me cross that off and cross that off. So I'm left with 1 parentheses 4p minus 6 equals 2. I'll distribute the 1. I get 4p minus 6 equals 2. But do you see, like, there's no fractions to deal with now? So multiplying by the common denominator, it's kind of like a nice trick because it gets rid of your fractions. If you don't get rid of your fractions in the beginning, you kind of have fractions the whole way through. I prefer eliminating my fractions first, actually. So if we're going to use the trick of eliminating fractions first, let's do it on this problem. I will do it on this right side. This side will be the side that I say, oh, let's eliminate fractions first. So we look at the 2 and the 4. You have to decide what the common denominator is. Well, the common denominator, remember, it's a number that both numbers divide into. So the common denominator would actually be a 4. So I can multiply this side by 4, and I can multiply this side by 4. If I multiply both sides by 4, my fractions do go away, because this simplifies, and this 2 and this 1 multiply together. I'm left with a 2 outside the parentheses and a 3m minus 2 in the parentheses. And over here, these 4's simplify, so I'm left with a 1. Look at that equation. It's pretty simple to solve, right? Just distribute 6m minus 4 equals 1. We can add 4. Did I make a mistake someplace? 4, 2. I think I'm doing okay. I just don't remember my answer turning out to be a fraction. That m equals 5/6. I'm going to do it a different way over here. And we'll see. So this 1/2 times 3 is 3 over 2m. 1/2 times 2, 1/2 times 2 is really 1. And that equals 1/4. So now I have to add 1 to both sides. And I have a 3 over 2m equals 1 and 1/4. I have to multiply by the reciprocal. So I'll multiply by 2 over 3. So that crosses out, and I'll multiply by 2 over 3, but I can't multiply with mixed numbers, so I have to change them proper. This turns out to be 5 over 4 times 2 over 3. I can simplify this 2 and this 4. That's a 1 and that's a 2. So my answer is 5 over 6. So guess what? I got the same answer both ways. I actually think that way was a little bit nicer. So if you find the common denominator and multiply both sides by that denominator, the fractions will go away. Holy cow. Look at all these fractions. I want to make the fractions go away. So I look at all the denominators. And I have to find the common denominator. I hope you agree with me that it's 15. Now there's a trick to this. I am going to multiply both sides by 15. I have to multiply, here's like the equal sign. So I have to multiply this whole side by 15. And this side by 15. I'm putting parentheses here, and I didn't put parentheses in these other two problems because you see they already had parentheses. So since it already had parentheses, I didn't have to worry. But this one I had to put the parentheses. And this one I guess is a bit tricky, trying to get rid of the fraction. I'm going to go into the margin and figure out what 15 times 1/3 is. I actually already know, but I thought maybe you needed to go into the margin to do it. Turns out to be 5. So this is a 5x. And then 15 times 7/15. 15 times 7 over 15. I could put a 1 underneath this and simplify. Oh, that's just a 7. And then this 15 times that 2/3. I can simplify again, and I get 10. Oh, that's such a simple question to solve. I can do this. 5x equals 3 divided by 5. So x equals, remember, you could just use that as your answer. X equals 3/5. You don't actually have to divide if it doesn't go in nicely. I wouldn't want to do it any other way, I don't think. Right? If I were to subtract 1/3 x from both sides, I guess I can do that. Thank goodness there's common denominators there, because 2/3 take away 1/3 is 1/3 x. So this one's not so bad, I guess, to deal with the fractions. Remember my last step when I have a fractional coefficient, so multiply by the reciprocal, because the 3's go away and the 1's go away. And over here, the 3 and the 15 simplify. And I'm left with I'm left with 7 over 5, which is not the same answer as over there, so I made a mistake. Let me check this out. I don't know if you guys saw the mistake I made and couldn't stop me because it was a video, but look, there's an X there, and I forgot to put the X here. So, all of this work I just did is wrong. Look at that. We all make mistakes sometimes. I'm not even going to re-edit this. I'm just going to leave it. Thank goodness I can find my own mistake. So really I'm supposed to subtract 5x from both sides, because that's a 10x, not just a 10. And then divide both sides by 5. So x equals 7/5. And I have the same answer. So I understand that maybe this isn't your favorite lesson. Okay, so one last question. I guess probably the hardest one. And I'll be careful not to make a silly mistake like I did on number 5. But let's first do it the way where you get rid of your denominators. So we have a 5, a 2, and a 10. The common denominator would be 10. So we have to multiply both sides by 10. There aren't any parentheses, so I have to put my own. I multiply this whole side by 10, and I multiply this whole side by 10. So I have to do the distributive property. And 10 times p is 10p, and 10 times that 2/5. 10 times 2/5. The 5 and the 10 simplify. It's 4 over 1, which is 4. There's this minus sign here, so be careful. So it's a minus 4. And on the other side, 10 times 1/2 p. I think it's easy to multiply by a half. It just means you take half of the number. So 10 times a half really is just 5. So I get a 5p. And then 10 times 9/10. You could go to the side if you need to. Maybe you already know it because these 10s just simplify. So I'm left with 1. Don't forget there was a minus sign there. I mean, 1 times 9. Phew, almost made a silly mistake again. All right, now this is pretty simple to solve. I'm going to subtract 5p from both sides. So 5p minus 4 equals -9. Add 4. 5p equals -5. Divide by 5. P equals -1. So we can decide to just deal with the fractions the whole way through. Right, and I could subtract 1/2 p from both sides. This way is not going to be my favorite way, I'll let you know. Some people like this way. My favorite way was definitely this other side. But 1p, take away half a p, I'm left with half p minus 2/5 equals -9/10. So now I have to add 2/5. But when I'm adding with fractions, I need a common denominator. So I'm going to make these 10. So that one has to stay what it was. And this one times by 2 times by 2, this is a 4. So -9/10 and 4/10 is -5/10. And over here I have 1/2 p. And since I'm a reciprocal kind of person, I will multiply by 2 over 1. And multiply by 2 over 1. 2 and the 10 simplify. So I'm left with -5 over 5, which is the same thing as -1. So I get the same answer, no matter which way I do it. So really, you can just deal with the fractions the whole way through, if that's what you like better, or you can get rid of the fractions and then solve an equation without them. This one, I'll tell you, I would do it just like, here, just like number 2. So this one refer to number 2. And do a check for it, please. There's only 3 questions in your problem set. This one, let's see which one we could refer to. It looks like number 4. Number 3 and 4 are pretty similar. It is like number 3. If you want to use number 3 as a reference. And then this last problem is like, it's like this last one we did. It's like number 6. Remember there's like a 1 in front of that W, in case that's helpful. So do the best you can on this. Of course, I will answer any questions you have. Just send them my way. Have a good day. See ya. Bye.